So, okay, dear students, in this lecture, we will discuss today the topic strong and weak electrolytes, means the electrolytes, type of the electrolytes, and also the conductors. Okay, because ultimately electrolytes dissociate into the ions and they flow the conduction. Or they are responsible for the conduction of the electricity in the electrolytic solution, yeah, in the liquid medium. Okay, not in the solid state. So the learning objective of today is to understand the strong electrolytes, what are the properties of strong and weak electrolytes, and how they flow the conductivity and dissociation and ionization process of the strong and weak electrolytes. Okay, so how they dissociate or how they ionize, what are the process of ionization? Like for example, we dissolve some, the electrolytes in the solution, then they are, there may be dissociation or there may be ionization of the compounds. Okay, so this ionization may be due to the, the polarity of the solvent. Okay, if the solvent is polar, non-polar, okay, then ionization may be affected. And the learning outcomes, students will be able to use the strong and weak electrolytes for various purposes, or ultimately for the conduction of the electricity. Okay, so we can by getting the knowledge about the properties of the strong and weak electrolytes, the examples. Okay, we can prepare something like just like battery, and we can the prepare electrolytic solution or ultimately for preparation of the battery. Okay, and for conduction of like electricity. Okay, we can use this battery for the various purposes. Okay, so the students can get, they can get the ideas about the, the electrolytes by this lecture. Okay, and job in industries. If you have the ideas about the strong and weak electrolytes, and you can, you can design such type of battery which have the high efficiency. And for example, if you can take the patent of that particular product you have prepared by using the strong and weak electrolyte, or for the by using the electrolytes, then you can get job in the industries which are preparing, the manufacturing the batteries or some other devices which are used as appliances in the, industries, home appliances, and other agricultural appliances. So many type of the fields are there where electricity is used. Okay, by using these appliances or by using these apparatuses and the instrumentations. So before understanding the electrolytes, we should know the concept about the electrochemistry, because electrolytes actually the flows electricity, and electricity study of the electricity, conduction of the electricity, flows of the electricity, generation of the electricity. We do the study of this concept in the chemistry, that is called electrochemistry. Okay, so this was the this matter actually taken from the Bockness and Reading, volume number 1 and 2. This is the name of these are the authors. Okay, their books is included this study, right? Electrochemistry. So electrochemistry is a branch of physical and chemistry which deals with the study of interconversion of electrical energy and chemical energy. And it in the electrochemistry generally we discuss that chemical reaction which take place at the surface of an electrolyte. Okay, so conversion of electrical energy and chemical energy into each other is it studied in the branch of physical chemistry that is called electrochemistry. Okay, and in the electrochemistry, we discuss generally the chemical reaction. Which chemical reaction which takes place at the surface of an electrolyte? Because when we prepare a cell, then in that cell we just put the electrolytes, sorry, the electrodes, cathode and anode, and also the electrolyte, and by completing the circuit of this cell, or the you can say battery, then the ions from, the flow of the ions to oppositely charged electrodes. Okay, for example, cationic electrode will move towards the negatively charged electrode, and anions will move towards the positively charged electrode. Okay, so they flows towards a positively charged electrodes. Okay, so when suppose positively charged ion moving towards negatively charged electrode, then what will happen? There will be a reaction. What reaction? The negatively charged electrode will give the electrons to the cation or the positively charged ion. So it means there is the insertion of the electron into the positively charged ion, or we can say there is reduction of the positive charge ion. So the chemical reaction is the reduction reaction. Okay, and there may be oxidation reaction. So generally, at the cathode, reduction reaction occur, while in the case of, if you take the anode, that at the anode oxidation process will be occur. Okay, oxidation and reduction reactions takes place at the anode and cathode respectively, right? So electrochemistry, we discuss the various properties related to a conductors. So in the electrochemistry, we discuss actually the conductors, because whatever the species, whatever the ion molecule species which flows which conduct the the electricity is called as the conductors. So here the electrolytes also act as the conductors. Okay, these are also act as the conductors. Now the definition of conductor, to which we call conductor, right? So the substance which allow to pass the current in their molten state or in aqueous solution are known as conductor, and the conductor can be classified into two categories. So which substance is called the conductors? Which allow to pass the current in their molten state or in aqueous solution or in the molten state, not in the solid state. Okay, so these are known as conductor, and the conductors can be classified in two categories. Conductors are actually the two types. One is the metallic conductors, and second is the electrolytic conductors. Okay, so the metallic conductors are also known as solid conductors. Solid conductors. So these are the properties of solid and conductor and the electrolytic conductors. So actually, electrolytic conductors are the aqueous conductor, or we can say these flow the conduct the electricity there in the liquid medium or the aqueous medium. Okay, or in the molten state also. Molten state is just like a plasma state. Okay, so in first property of the metallic conductor is, in metallic conductors, the conductance arises due to the flow of electrons. Flow of the electrons in the solid devices. Just if we talk about the wire, wire, electricity wire, then there is the conduction of the electricity is due to flow of ions or by the flow of the electrons. So this is due to the flow of electrons. So in the solid conductors, the electricity conduction is due to the flow of electrons. While if we talk about the electrolytic conductor, then here the conduction of the electricity is due to the flow of ions. Right? This is the basic difference between the metallic or electrolytic conductors. Right? Second thing is, when we pass the current through metallic conductors, then chemical reaction doesn't take place. So in case of metallic conductors, in case of wires, there is no chemical reaction. Okay, there is no chemical reaction. But if we talk about the electrolytic conductors, then there is there is a chemical reaction. Which the chemical reaction takes place. It may be either oxidation or the reduction, or both type of the reaction may take place simultaneously. Okay, in the electrolytic conductors where we pass the current. For example, in the cell, when we complete the circuit, the electrolytes for the ions will move towards the positively charged electrodes. Okay. Third point is, metallic conductors always follow Ohm's law. Metallic conductors always follow Ohm's law. So actually, the conductivity, current, or the electricity produced by flowing the current is directly proportional to the volt. This is volt of the light. This is the Ohm's law. While while the electrolytic conductors, just a moment. In the electrolytic conductor, there is mass transport is observed, and the electrolytic conductors follow Faraday's law. Faraday's law. Okay, they follow the Faraday's law. So according to Faraday's law, W is directly proportional to the Z multiplied by I multiplied by T. I mean, how much mass will be transferred? Okay, this is depend upon the charge of the ions multiplied by the current multiplied by the T time. Time forward the current is passed through the electrolytic solution. Okay, so this is the Faraday's law. And the next point is if we increase the temperature, then conductivity of the solid conductors decreases due to the atomic vibration. So if we increase the temperature, if we increase the temperature of the conductors, solid conductors, if you talk about the wire. So in case of the wire or the solid conductors, if we increase the temperature, if we increase the temperature, then the conductivity will be decreased. Why this is so? Because at high temperature, as we increase the temperature, then the atoms which is present in the wire, I mean the crystal of the wire, we can say, okay, or the metals. Suppose we have the metal, then in the metal, so many atoms are present in the metal of the particular element. Okay, so if you talk about the wire, in the wire, so many in the the lakhs and the crores of the atoms are present. So and they are arranged in a sequence in the just like in a uh, crystalline form, crystal form. Sorry. So their arrangement, atoms arrangement is generally the perfect arrangement in the mm, metal. Okay, metal crystal. Okay, but if we increase the temperature, then these atoms just vibrate, and due to this vibration, there is blockage in the hole. There is blockage in the hole or in the pathway pathway of the migration of the electrons. So if the electrons pathway to move is blocked due to the atomic vibration at increasing the temperature, then conductivity will also be decreased. Okay. If in case of electrolytic conductors, if we increase the temperature, then conductivity also increased. But in case of electrolytic conductors, temperature, if we increase, then conductivity will also be increased. Why this is so? Because we increase the temperature, the reaction medium temperature will also be increased, and and the ions or electrolytic ions will get the higher energy. If they will get the higher energy, then their kinetic energy will be high. If their kinetic energy will be high, then their movement will be high. Their movement will be faster. So if their movement is faster, means their movement towards the electrodes, positively charged electrode will be faster. If this will be faster, then their reduction and oxidation process will be fast, and electricity will be generated up to with the increasing rate. Right? Means the conductivity will be increase. So the next point is in metallic conductors, mass transport is not observed. In metallic conductors, mass transport is not observed. While in the case of electrolytic conductors, mass transport is observed. There is transport of the mass in the electrolytic conductors, while not in the metallic conductors, because there is only the flow of the electrons. Now the general properties of aqueous solution. Solution Solution is a homogeneous mixture of the two or more than two components. Of these component, one will be solute and second will be solvent. Means solute and solvents are completely mixable into each other, and they cannot be separated by the mechanical work, by the mechanical method. Okay, so this is called the solution. And what is solute actually? So the component that is dissolved, the component that is dissolved in the solvent is called the solute. So suppose we have two components, solute and solvent, then which will be solute and which will be called as solvent? So the component which is in the less quantity is called the solute, and the component which will be present in the measure quantity is called as solvent. Okay, so we dissolve actually the less quantity into the higher quantity, right? So the component that does the dissolving, generally the component present in the greatest quantity is considered to be the solvent, while the component present in the less quantity is called as solute. Okay, so the aqueous solution are those in which water is the solvent. So in all the aqueous solutions, water is the solvent. For example, if we prepare the uh, water of the salt, sorry, the solution of the salt in water. I mean, we are dissolving salt, eating, I mean, you edible salt to the NaCl. So if we dissolve NaCl in water, then water will be solvent. And this solution of the NaCl will be called as aqueous solution of NaCl, right? Just 1 minute. Yes. Now the electrolytes and non-electrolytes. So which species will be called as electrolyte and which species will be called as non-electrolyte? So which species will be called as electrolyte? The substance that dissolved in water. Substance that dissolved in water produces a solution that conducts electricity. So a substance that dissolved in water produces a solution that conducts electricity. It's called as electrolyte. So if you talk about the NaCl, so this NaCl in this solid state, just a moment. Yes, that is correct. So a substance that dissolved in water produces a solution that conducts electricity. So suppose this is a substance and this is dissolved in water, and now this produces electricity. This conduct electricity because when we dissolve an HCl in water, then it is decomposed or the ionized into the Na plus and Cl minus ion. Okay. So by this ionization process, there is formation of ions, oppositely charged ions, and these ions will migrate towards oppositely charged electrons. And when they flows towards electrode, then they produce electricity. Due to the flow of these ions, they produce the electricity, right? Now, second thing is non-electrolyte. The substance that dissolved in water produces a solution that does not conduct electricity. So a substance, if we dissolve this in the solvent and this is not producing the electricity, then this is called as non-electrolytic, non-electrolytic substance. that does not contain actually the ions. So if you talk about the glucose, this is the glucose C12S22 and O11, मतलब oxygen 11. This is found in the solid state. When this is dissolved in water, then the aqueous solution of this compound will be formed. But there is no dissociation or ionization of this compound into the ion. So if there is not the formation of ions, then there is no migration of this compound towards electrodes. If there is no migration of this compound towards electrode, then there will be no reaction takes place, no reduction, no oxidation reaction will be takes place at the electrodes. So if no reaction will be take place, then there will be no conduction of the electricity, right? So non-electrolytes solutions are actually the non-conducting solution, or we can say non-electrolytes are the non-conductors, and electrolytes are the conductors because they conduct the electricity in the solution. Now the next terminology used in the electrolytic solution, or you can say in the electrochemistry, is the dissociation. So ionic compounds separate into constituent ion when dissolved in solution. So this is the actually the initial. This is the ionic compound, initial, and this separate into the constituent ion. The constituent ion in the NaCl is the Na plus and Cl minus ion. So this is dissociated into the Na plus and Cl minus ion. Okay. So this process where ionic compounds separate into their constituent ions when dissolved in the solution, then this process is called as dissociation. Okay, dissociation. While the second term is ionization. So the formation of ions by molecular compounds when dissolved. Formation of the ions. This is the compound HCl. HCl. Actually, HCl is not ionic compound. This is what have the the covalent properties. And when this dissolved in the water, then it is ionized into the H plus ion and Cl minus ion. Okay. And if you talk about these ammonia and water, so ammonia and water are also the covalent compound. There is also covalent bond. There is no ionic bond in these two compounds. But when they react, ammonia in the gaseous state and water found in the liquid state, here G means gas state and L means liquid state. Okay. So when ammonia dissolved in water, ammonia gas is dissolved in water, liquid water, then there is formation of NH4 plus ion and OH minus ion. So these are actually the molecules. These are the molecular compounds. Okay, they are found in the molecule, not found in the form of ions. But by the reaction, they are converted into the ions. This compound is not found in the form of ions. But when dissolved in the water, then it is found in the form of ions. Then this process is called the ionization. Means a simple compound, a neutral compound, when it dissolved in water and it get ionized, then that is called the ionization. But an ionic compound, when an ionic compound, already this is the ionic compound, NaCl is the ionic compound. Because in the solid state, NaCl is found in the form of Na plus and Cl minus ion. Okay? In a one row, there is the presence of Na plus ions. In the second row, there is presence of Cl minus ion. Or we can say suppose at a center, at a particular center, Na plus ion is present, then Cl minus ion will be surrounded by these Na plus ion. So means NaCl compound is found in the form of ions, constituent ions. Okay. So this is called dissociation and this is called ionization. Because they are the formation of ions from the neutral molecule. They are not the formation of ions. There are already the presence of the ions Na plus and Cl minus ion in NaCl molecule. Okay, but these are actually when dissolved in water, then these ions are actually the dissociated. They separated, just separated, not formed in the form of ions. They are just separated. They are already formed in the form of ions. Okay, so these terminologies are very the important. It is very much to know about the difference between the dissociation and the ionization. Now, the next is strong and weak electrolytes. So now, what are the weak electrolytes? We have discussed it already. These are the electrolytes when we dissolved in the water or the the solvent, then they the ionized, and by this ionization, sorry, they dissociated into the ions, and by dissociation, they formed the ions, or their ions are separated, and they move towards oppositely charged electrodes, and they conduct the electricity. Okay, so these are the electrodes, sorry, electrolytes. So now, which will be the strong electrolyte and which will be the weak electrolyte? So the strong electrolytes are those substances which 100% dissociate. When we dissolve this in the solvent, the substances 100% dissociated into the ions. Suppose we dissolve 1 mole NaCl, 1 mole NaCl or 1 mole NaOH into the water, then the whole 1 mole NaOH dissociated into the Na plus and OH minus ions, right? Then these are called as strong electrolytes. For example, NaCl, for example, NaOH, for example, maybe other strong acids, very strong acids. They have the property of strong electrolyte. Okay, so all water soluble ionic compounds, strong acids and strong bases are the strong electrolytes. All the water soluble ionic compounds are strong electrolytes. All the strong acids are strong electrolytes. All the strong bases are strong electrolytes. Because strong acids and strong bases means what? What do you mean by the strong acid? Strong acids are the compounds which gives H plus ion easily. H plus ion easily means positive charge easily, proton easily and in the maximum number. It's called the strong electrolyte, strong acid. So actually when we dissolve strong acids or strong base, just for example NaOH, then it will be the completely dissociated into the solution. Now the weak electrolytes, they are partially ionized in the solution. Weak electrolytes are partially ionized. Suppose, for example, we dissolve 1 ml of, 1 mole of, we dissolve 1 mole of substance into the solvent, then only the 0.1 mole of the substance get ionized, and 0.9% substance do not ionize. Then in that case, we can say that the compound is partially ionized, and this is called weak electrolyte. Okay. So for the example, weak acids and weak bases, all the weak acids and weak bases are actually the weak electrolytes, and they exist mostly as the molecular form in solution. They mostly found in molecular form, not in the ionic form. Okay. Now the table of the strong acids: hydrochloric acid. HCl, when we dissolve this in aqueous solution, I mean the water, then this is dissociated into the H plus ion and Cl minus ion. Just like this, hydrobromic acid HBr dissociated into H plus ion and Br minus ions. And same like this, hydroiodic acid HI dissociated into the H plus and I minus ions. Nitric acid in the H plus and NO3 minus. Chloric acid HClO3 H and ClO minus ClO3 minus. Perchloric acid HClO4 aqueous is dissociated into the H plus ion and ClO4 minus ion. Like this, sulfuric acid is dissociated into H plus ion and SO4 minus ions. So all these are actually the ionization equations. There is ionization of these acids, okay, and very fast with the very fast rate. So these acids are called actually the strong acids because they give H plus ion protons very easily. So note that although each sulfuric acid molecule has two ionizable hydrogen atoms, it only undergoes the first ionization completely and effectively producing the H plus ion and one HSO4 minus ion per HSO4 molecule. And the second ionization happens only to a very small extent. Okay, so completely ionization is of the only one H plus gives completely H2SO4 molecule. Note the second easily. Another example of the weak electrolytes or weak electrolytes. This is weak acid is the weak electrolyte CH3COOH in the aqueous medium. So this is dissociated into the CH3COO minus and H plus ion. Okay, and the weak base NH3 plus water. These are ionized in the form of NH4 plus and OH minus ion. So this is the weak base. Which is weak base here? Ammonia is weak base. Because when this dissolved in water, then this accepts the H plus ion. And the H plus ion or the proton shifting moiety is called the base. Right? And the proton donor is called the acid. So this is the acid and this is the base in this direction. So note double arrows indicate a reaction that occur in both directions. A state of dynamic equilibrium exists. Okay. So here this both double arrow in both the direction, they denote actually the dynamic equilibrium. There is dynamic equilibrium between reactant and product. In this action proceeds in both the directions. Now, how we can distinguish that a particular solution is of electrolytes or not? Okay, or it is of strong electrolyte or weak electrolytes, or it is of non-electrolytes. So this is for distinguishing this electrolytes or non-electrolytes. We have carried out the experiment was done, and this is the solution of non-electrolyte actually. We don't know it is the solution of electrolyte or not, but this is the solution, okay, of the electrolytes of the substance we can say, and we completed the circuit, okay, and they put the they connected this bulb with the circuit, but due to the due to this solution due to the solution of this substance, there is no flow of the conductivity, no generation of the conductivity, electricity. No generation of the electricity, then there is no lighting of the bulb, no light in the bulb. Okay. While if you talk about the, so we can say that this solution is of non-electrolytic solution. Okay. While the second is weak electrolyte. So the weak electrolyte, in the weak electrolytes there are ions, but only few molecules are in the form of ions. This is the molecule. This is the molecule. Okay. This is molecule, but these are the ions. green ions. And this is the ion, positively charged ion, or this is negatively charged ion. So only few molecules are, they dissociated into the ions. So there is due to the flow of these ions, there is conduction of the electricity, generation of the electricity, but not too much because only few compounds are dissociated into the ions. So there is migration of the only few ions towards the electrodes, and this produces the electricity very few level. So this is called the weak electrolytic solution. But if this bulb is lighted very much, okay, then we can say that the solution is of strong electrolyte because strong electrolytes are completely dissociated into the ions, and the bulk number of the large number of these ions migrated towards the electrodes and produce the electricity. Okay, so by this method we can easily understand, explain, or distinguish also the types of electrolytes. That the electrolytes is of the strong or weak or non-electrolyte six varieties. Okay, so now the MCQs, multi-choice question. The first question is, when electrolyte is dissolved in polar solvent, then what will happen? It is dissociated into the ion. Its small fraction dissociated into the ion. Only 50% portion is dissociated. None of these. What will be the correct option in case of weak electrolyte? When we dissolve weak electrolyte in polar solvent, what happens? So we have discussed this thing in the previous slides. Then that the weak electrolytes only dissociates small fraction. Only a small fraction of the weak electrolytes dissociated into the ions. So B option would be the correct option. Now the second is, when electrolyte, strong electrolyte is dissolved in polar solvent, then fill in the blank, dissociate into ions. So then it is completely dissociated with the ions. Small fraction only 50% or the. So for strong electrolytes, we have discussed already that strong electrolyte when dissolved in polar solvent, then it is completely dissociated into its ions, right? And the question number third, substance that dissolved in water produces a solution that conduct electricity is called. So when a substance dissolved in water and it produces electricity, then what it will be called? Acid, base, electrolyte, and none of these. So this will be called as electrolyte. Okay, because electrolyte conduct the electricity. Question number 4. Dissociation. Dissociation. Sorry, this is actually the fill in the blank. Yes. Fill in the blank. Any compound separate into constituent ion when dissolved in solution. So which is the process it is? Dissociation, ionization, association, or none of these. So dissociation, because by dissociation or in the process of dissociation, ionic compounds separate into the constituent ions when dissolved in the solution. Okay. And now, which is the example of weak electrolyte? Acetic acid, H2SO4, NaOH, HCl. So weak acid is the weak electrolyte actually. So here, which is the weak acid or which is the weak base? So this is acetic acid is actually the weak acid. H2SO4 strong acid. NaOH strong base. HCl strong acid. So answer would be A. This is the weak electrolyte. The question number 6, which is not the example of weak electrolyte? So which is not the example of weak electrolyte? H2SO4, NaOH, and HCl. Actually, H2SO4 and HCl both are strong acids. While if you talk about the NaOH, it is strong base. So all these three are not the weak electrolytes. So answer would be the none of these. So if these are not weak electrolytes, then what are these? These all are the strong electrolytes. Okay. Now, which is the example of strong electrolytes? NH4OH, H2CO3, H2SO4, and none of these. Which is the example of strong electrolyte? NH4OH? No, NH4OH is actually the weak base, right? Not it is actually base. This is yeah, it is can be put in the category of weak base. Okay, and H2SO4, this is a weak acid, and H2SO4 is the strong acid. So we have discussed the thing that the strong acids are actually the strong electrolyte. So the H2SO4 will be the correct option because this is a strong acid. Now the MCQ is question number 8. Formation of ions by molecular compounds when dissolved. So in which process ions are formed by the molecular compound? When this compound is dissolved in solvent, what will be formed? Sorry, what will be the process? Dissociation, ionization, and association. So the correct option will be ionization because there are formation of ions by the molecular compounds by the dissociation process. Okay. And now the question number 9. The dot substance that dissolved in water produces a solution that does not conduct electricity. So which compound on dissolution does not produces electricity, does not conduct electricity? Non-electrolyte, base, electrolyte, none of these. The base may be an electrolyte or electrolyte also conduct the electricity. So what would not conduct the electricity? Non-electrolytic solution or the non-electrolyte substance. Okay. Now, which is incorrect statement? Statement number A. Solution is a homogeneous mixture of solute and solvent. Is this correct? Yeah. This is correct option because a homogeneous mixture of the components is called the solution. Okay. The option number B, solute. The component that is dissolved in solvent is called the solute. It is also correct. And this is present in the solution in less quantity. And the next is solvent. C option is solvent. The solvent, the component that does the dissolving, generally the component present in the greatest quantity is considered to be the solvent. Okay, the solvent is also present in the great quantity than the solute. And solvent dissolve the, this does dissolve the component that is called solute. So this for solvent, this statement is also the correct statement. And the option number D, aqueous solutions are those in which water is not the solvent. So this is the incorrect option because In the eco solutions, water will always be the solvent. Okay, water will be the solvent always in the eco solution. These are the reference books related to these. For they includes the study about the there are also other books like ESP, Puri Sarma Patania. Thank you. That's it from my side. And you can ask question, query, and confusion if you have. I would be very happy to answer you. Thank you. Have a good day.